One of the last things we want to talk about are extreme values when talking about quadratics. If we have a parabola that's opening upward, we know that our vertex is located at the lowest point possible of my y values. The vertex will be located at h, k and is what we call the minimum point. Minimum point. And most likely you'll see it as p of h, right? So whatever our x value is, we plug it into our polynomial or our function, and it's going to give me the y value of k. And k is what we call the minimum value at or of p of x. Likewise, if we have a parabola that opens downward, our vertex is located at the tippy top, and it is said to be the maximum point. And we would say p of h is equal to k, and k is the maximum value of my polynomial or my quadratic p of x. I want to go down now and talk a little bit about using this information with certain examples here. So let's say we have a ball that is projected directly upward from an initial height of 100 feet with an initial velocity of 80 feet per second. We can use that information and stick it into this physics equation. So our job is to write a function s of t using the fact that we have negative 16t squared, where t is time, and our v naught or v sub 0 here is our initial velocity of 80 feet per second, and then s of 0 is our initial height of 100 feet. Now for my classes I will just go ahead and give you this equation, but I wanted to make sure you understood that it was coming from physics and what those little knots meant. In other words, the v naught is the initial velocity and s naught is equal to the initial height. Okay, so let's talk about that. Now it says, part B says the figure shows that the point, and it has the point 4.8 seconds and 115.36 feet. Lies on the graph of the function. So that's this guy right here. And it says, what does this mean for this situation? So this is part A. For part B, what it means is that after 4.8 seconds, after we threw it up, that it was projectile was going directly up, after 4.8 seconds, that the ball is 115.36 feet above the ground. That's what it means. So for part C, it says, what point on the graph will answer the following questions? It says, after how many seconds does a projectile reach its maximum height, and what is the maximum height? So what we're going to find out, what we know about extreme values, is that C, where it's asking for maximum height and maximum and the time in which it takes to get to that maximum height. So I'm going to write that down, that the maximum height and the time that it takes to get there is actually going to come from the vertex. Remember, we talked about how if we had a parabola that opens downward like this, then the vertex would be the maximum value, or that in our case, the maximum height. So let's go to part D. What is the equation that we need to solve to determine the interval of the height that is greater than 160 feet? It's not asking us to solve it, it's just asking us what would we solve. Well, if we come over here and we find 160 feet, let's say this is 160 feet. So they're asking us, how would we solve this? Well, we know we have our equation of negative 16t squared plus 80t plus 100, and remember that's height. So we want that height to be greater than 160. So we want this height of my ball to be greater than 160 feet. So that's what we would be solving. Let's go to part E. Part E says, what is the equation to solve to determine when the ball will hit the ground? And again, it didn't ask us to solve, it's just asking us, what would we solve? Well, we know that negative 16t squared plus 80t plus 100 is the feet above ground, but if we set it equal to 0, it will tell us when it hits the ground. And in fact, we're going to find two numbers, one over here, which is a negative time, and then another one over here. And we can see that the negative really does not apply to our situation, because at 0 it was up here at 100 feet, and then it went up, and then it came back down. So we're actually just looking for the x-intercept over here. So we're looking for solving this quadratic equation to find the t value for that. And that concludes this video.